Okay guys, this is another example on indeterminate truss. Indeterminate truss. So if you look at this truss, the reactions are AY and AX2 and 1 BY. So we have reactions R for checking determinacy equal 3. The force in each member is counted as one unknown. We use the term B, spectrum B. So B is the number of members. 1, 2, 3, 1, 2, 3, so 6. So total unknowns, we have 9. How many joints you have? Number of joints, 1, 2, 3, 4. So 4 joints. Each joint gives you 2 equations in a truss. Sum in the force in the X, sum of the force in the Y. So we have 8. So 8 equations, 9 unknowns. So this is indeterminate to the first degree. First degree. Indeterminate to the first degree. Okay? Now look at the truss. For truss there is external kharij, external determinacy and internal determinacy. So the external determinacy, it means can you find the reactions? Yes. Everybody can find the reaction. Ax equals 0, 4.5 here, 4.5 here. 4. So externally determinate. Internally indeterminate. It means it's indeterminate. Good? So if I give you this one as also pin, it will be indeterminate to the second degree. It will be indeterminate to the second degree. To unknown, to redundant. You may select this one as one redundant to find the reaction to the X, and one member or 2 members. You need to remove degrees of freedom or restraint to give freedom. تشيل الريسترين حتى تعمله redundant. Good. So this is easy to check. Let's see. Yeah, if the question is, I don't know, A, B, C, D. Sometimes the question select the force, calculate the force in member C, D. You select that force. And member A, D, select that force. Or calculate the force in every member of the truss. Anyone. Anyone will work. Which one do you want, guys? This? Yeah, this is the best option. Why? This is the best option to select. And when you select this as redundant, it's kind of, you are removing it. It's cheap. Why? If you remove this one, this joint, it will end up with 2 members. And this joint with 2 members, 2 zeros. If you remove this one, this will be 2 members, right? But this will stay 3. This one has the reaction, through the reaction. Everything worked. So, but the best option, I think, is to cut this one. We will cut this one, the amount of delta AC. It means 0 force. There is no force in this movement. Good? So, if we do that, we will have 2 segments. Delta CD, sorry. Delta C. Then you have this. This is cut. And the loading is here. We have 9 here. So the angles we have here. See, this is 3 and 4, 3 and 4, and this is 4 and 7. So we have the angles. We have the slopes. This number is 4, 7. This number is 4, 3. If you like to find the angles, no problem. Tan inverse 3, 4, to find this angle. Tan inverse of 7, 4, find this angle. Or keep it like this. بعد في ناس بيحبوا هيك في ناس بيحبوا. So we have plus this one at CD. What do? We put the unit load. We put the unit load. And kind of we're trying to bring it back to that thing. So we put unit load in this member, 1, 1. So this delta will be F CD and member CD. Member CD from force and member CD. So we need to solve this and we need to solve this. Okay. This plus that. Look, you have two trusses now. This truss and this truss. They are determinate. They are determinate. For this one, you need to find this delta. You need to find this delta, which is delta CD. You need to find this delta. So to find delta in trusses, we analyze the truss for the forces. You find the force in each member due to the loading and capital. Then you go to the location that you want delta or the delta to be calculated. Here. You put unit load there. Then you calculate the force in each member due to this unit load. And small. Then delta will be and capital and small L over EA. For each member. It's the sum. Okay? Then you go to this guy. You calculate the force in each member due to this load. Then you put the same load here, then you calculate the force in each member. So it's n squared. N squared is the second case for this. Let's do this. So how much the force in this member? 0, 0 from this joint. From this joint. Any joint with two members only. No external load at that joint, both are zeros, regardless of the axis. Hey, regardless. Any joint with three members, two of the members on the same line of action, the third is always 0. If there is no external load there. You know this, right? So that's 0, 0, 0. Okay. Reaction we said how much? 4.5. 4.5. Now look at this angle here. So this number here is 4, 3. Okay? This number is 4, 3. The vertical component of this number, when I take this joint, cut here, this guy, sine theta, equal 4.5. Compression. So 3, 4, he said, this is the common triangle, the 3, 5, 4. So listen again. This member, sine this angle, will give you a component in this direction. If this is up, that component must be down, it means it's compression. Yeah, this force, sine the angle which is 3, 5. So this number will be 5, 3 times that. Compression. So 5 over 3 times 4.5. Let's do this. Yeah. How much is this? 9 over 2. 9 over 2, right? This force will be 9 over 2 times 5 over 3. So 3, 15, 7.5. So this number is, the force is 7.5 C, compression. Anything you calculate, put circle around it, put دايرة عليه. You don't have to do this. Okay, look at this joint now. Look at this joint, symmetric. If this is 7.5, this is 7.5, symmetric. Why? Because the equilibrium in the x-axis, you just have this one and this one. So this is 7.5 C. Now look at this one. Here. Sum of the force in the x direction equal to 0. This cosine the angle equal this guy. So this one is 7.5 cosine the angle, which is 4, 5. 4, 5. Cosine this angle is cosine this angle. 4, 5. يعني هاي الشباب بيغلطوا فيها فعلا الساين والكوساين 6 بالعشرة ولا 8 بالعشرة 3 over 5 is 1/6 4 over 5 is 1/8. This is always the case. This has been sometimes. So cosine this angle, right? Which is cosine this angle here, which is this over that. Good? If this is compression, it means the component to the right. This one will be component to the left, which means it's tension. So this number will be in tension. How much? 6. So this number is 6 T. Everything is in kilonewton. 6 done. And you should do this fast. Because it's just a step for the calculating the deflection.
Reaction in x direction.
0.
0.
So sometimes you don't need to calculate the reaction. No need. Sometimes you can say, لا احتاجناه هون. No, you can just come here and calculate this. Those are equal, right? Those are equal. So they both cosine this angle will give you component up. So this force F cosine the angle times 2 equal 9. If you want this joint, yeah, you can calculate from this joint, or you can check it. This one is obvious extension. Look, if you are pushing this one down, this will go to the right, right? So this one will be in tension. But why tension? Look at this joint here. Right? We have this number compression, 7.5. This one, this is 0. And this is 4.5, right? So this one must be this. Any force going out of the joint, it means the member is in tension. Any force in the joint, it means the member is in compression. Vice versa, العكس. If the force in the member is in compression, when we do the equilibrium, you put it in the joint. We should put 7.5 minus. This is 7.5 with the direction. It means 7.5 compression. And this is 6 tension. We should put 7.5 minus. This is 7.5 minus. And you should be master of this. Come to this guy here. So there's one here and there's one here. So the reaction here is 1.5 and 1.5, right, Omar?
Yes.
It's not yes here, come on. 0, no reactions.
Internal force.
One up, one down. If this one, if the second component gives you reaction, it means it's wrong. معناها high plus high is not equal. See? So the internal loading should not give you anything.
Internal force,
Yeah, it is. Internal force, the member is cut. It's not internal force. It's 2 segments. This piece has 1 and this piece has 1. It's external force. But look at those. Sum of the moment here equal to 0. To find this, right? 1 times 4, 1 times 4, they cancel each other. So this is 0. If this is 0, then this is 0. Good? This is the case. Look. This is the case. Let's go to this joint. This joint here. We have this number and we have this number. We don't know. So this is what? 1. Now, this is 1 down. In the x direction, there is no force. Only those 2 members. There should be, it means they are equal to each other. The angle is the same. It means they are equal. Good? So those force in this number is equal. Now, they should give you component to balance this. It means they should give you this so they can give you a component up. So they are in compression. They cancel each other in the x direction and they add to resist this. And it's obvious, guys. This is tension here, they should be in compression. It's the common sense. Good? How much is this angle we said? This angle is the big one. Here. Or this number here we said, how much? 4, 7. Right? 4, 7. Square root of 49 plus 16. 65. Good. So look again. We need sine this angle. Sine this angle. You should figure out this. يعني لازم تقعد توسع تتأكد منها. تمام. تمام. He's saying you want the vertical, this is the vertical. You want the horizontal, this is the horizontal. Good. So if this is F, this is F. 2 F sine this angle, which is 7 over square root of 65 equal 1. Equal 1. Or minus 1 equal 0. Take 1 to the other side. This one. Yeah. So F equal 0.57 in compression. This is compression. We assume this compression, we got it positive. It means our assumption is correct. يعني if you assume the tension, يعني في ناس this is how they solve truss. They assume the force tension. If they got a tension, a positive it means tension. If they got a negative it means compression. It depends. If you don't understand, sometimes it's hard. مرات it's really you cannot tell. ما تقدر تعرف which one like this. You cannot tell about this one. You can't. You guess, but you can't. We'll see. Sometimes you can, but for easy things like this you can. So this is compression. So this guy is 0.57 C, and this guy is 0.57 C. Good? So let's go to this joint. This is joint C. And this is joint D. Let's go to joint D. Same case, but the angle is different. So we have one up, we have this, and we have that. So look at this. It should be in tension. It should be in tension. And this angle is the 4, 3, 5. 2F sine this angle. Sine this angle 3 over 4. 3, 5 equal 1. 5 over 6, which is 183. 5 over 6 tension. So this number is 0.833 or 83. 833. So at the end, if you get something like 5.99, it's 6. Because there is some rounding in here. If this is the case, this is what's left for us. This is what's left for us. Someone may come and just find the reaction, then find it. Or you don't need the reaction. Cosine. Yeah. Yeah. This is what you have. You have this number, you have this number, and you have the horizontal number. Now look, this number is what? Compression, it means N, the joint. 0.57. This number is tension, right?
Yes.
So that's tension, how much? 0.833. So this number we will see.
Tension,
it depends. This cosine, this one, this cosine. The cosine is decreasing as we increase, right?
Yes.
So this will be in compression. And cosine is 0, how much? 1. Cosine 90, 0. So the cosine is decreasing as the angle increases. Since this is bigger than this should be in compression. يعني انت قاعد بتشيل ترس لفوق, those are getting closer to each other, so it's in compression. You are pulling up, this will go this way, it means in compression. So this force will be the force in number A, B. This one A, B, or call it F, A, B. We assume it to this direction. It is equal to this minus this. Equal 0.833 cosine the angle, which is 4, 5. minus 157 cosine the angle which is 4 square root of 65 equal 0. We get AB. By the way, this is tension, right? And this is tension. How much? 138. Exactly. 138. Yeah. This makes a difference. Conversion. Conversion. Good? A little bit. It depends on how significant. يعني how significant the number. مرات significant يعني مرات كيف significant. So you can say how much 0.003 divided by 138 could be like 2% or 1%. Or something like that. It's okay. Now, what do we have? We have sum of n, I, L, I over E, I, A, I for each member, but they are constant, so it's EA. For all the members, that's delta. Delta C. 0, 0, 0, 0. So this times that, gun. This times that, gun. This times that, gun. So we for the big delta we have three numbers. 7.5 times 0.833, remember? Times 2, those are compression. Then 6 times compression, everything will be compression. But it means all minus. So let's do it. So equal 7.5 times 0.833. So this is negative. This is negative. Times 0.833 times what's the length? 5. The length is 5. Over EA is out. Keep EA out. 1 over EA. Factor. Times 2. We have this number and this number, they are the same. Okay? Plus this number, 6 times 0.383 negative. The 0.383 is negative. Times what's the length? What's the length of this number? 8? 8. 4 and 4. 8. That's your delta CD. That's your delta CD. How much? both negative.
سالب 7
You add يعني they are added.
تمام صح.
شو يعني؟
بس نيجي نقدم على 80 نيجي
EA. Good. 80.86. Okay. So what's F? CD equal member by member. And the first one you do is this number, so you don't forget it. The first number you do is this number. There's 1 here. So 1 square 1 times. So let's do it 1 time. What's the length? 4 over everything over EA. everything. So 1 square, which is 1 times 4. Tension. Everything should be positive here. Everything. And square. And don't look compression or don't put minus square. Just put it. We know it. Second one, we have 2 of them. So 2 times 0.57 square times the length, which is square root of 65. This thing. Then we have those 2 plus 2 times 0.833 square times 5 plus the last one 1, which is 1. The force is 0.383 square times 8. This 2 means two numbers. This 2 means 2 numbers. Add them. Seventeen. 17.35 over EA. Now, if you are doing an exam and find the force FCD, this over this, and you move on, you'll see it's compression. This over this, it means the force is in compression.
Yes.
What's the compatibility? CD plus FCD equals 0. We get this one negative, minus 86 over EA will cancel, plus 1 minute. I'm wrong. It will be positive. It will be intention. I am wrong. 17.35 equals 0. So this is minus, plus this is the equation to keep the sign. If you get this one negative, you put it negative. If you get this one negative, you put it negative. This is always positive.
4.6.
So we got FCD equal 4.66 kilonewton, right? Kilonewton tension. That's the answer. That's the answer. How much? 4. 6. Tension. 4.66 tension. Good? 4.66 tension. Now, you have a book. هذا مع كتاب آخر. What's the edition? 7. You don't have the impressions. Keep this. I need it. So the 6 and 7 edition. 6 and 7 edition. حلينا السؤال منير في كان. Remember we needed this case. مش احتاجنا هاي الحالة. Okay. Open this. See, in this sheet, which is the 8th edition, which is the PDF file you have it in the website, it says, for this case, M, which is the last case here, it says V equal M naught X over 6 EIL X square L square minus X square, right? And here it says something else. Flashness. They are not equal. This one. I derive this one using the conjugate theorem or the double integration. It gives you this. The derivation based on the double integration is this one. This is not like this. I'm not sure if you flip the axis. I don't think it's the same. Just be careful. You use this. L square minus x square. In the new book, they changed this one to L square minus x square. This is not L square minus x square. Okay? Thanks to Rafai for noticing this. Okay, so you work on this one or the book version, the PDF. Or this one. Or correct what you have. صلح العين. Good? So now, find the force in each member of the truss and submit it as a quiz. Calculate the force in each member of the truss. Now just one. Okay, a new sheet. You have this one, 4166. 4166. Find the